Hello guys, my name is Ayush Kumar and my USN is 1V22CS022. Today I'm going to discuss about Unicast routing techniques for mobile AD HOC networks. A mobile AD HOC network MANET is an autonomous system of functionality equivalent mobile nodes which must be able to communicate while moving. Without any kind of wired infrastructure at this end, mobile nodes must cooperate to provide the routing service. Transmission bandwidth, CPU time, and battery power, and the required ability for the mobile ADHOC networks by focusing on the main solution proposed in the literature to cope with mobility. The paper surveys the techniques adopted for the case of unicast routing, that is, when it is required to send a packet from a source node to a destination node by illustrating how they are introduced into the main respective protocols. Introduction. The term MANET mobile ad HOC network referred to a set of wireless mobile nodes that can communicate and move at the same time. No fixed infrastructure are required to allow such communications. Rather, all nodes cooperate in the task of routing packets to destination nodes. This is required since each of the network is able to communicate only with those nodes located within the transmission radius R, while a source node S and a destination node D of the MANET can be located at distance much higher than R. When S wants to send a packet to D, the packet have to cross many intermediate nodes and for this reason MANETs belong to the class of the multiple hop wireless networks. Proactive protocols. The advantage of these protocols is that a path to the destination is immediately available so that no delay is experienced when an application needs to send packets. In some cases, this can be useful. As for interactive applications, the main mechanism adopted in proactive protocols are the following: to increase the amount of topology information stored at each node, to avoid loops and speed up protocols convergence, to vary dynamically the size of route updates and or the update frequency, to optimize flooding, to combine DV and LS features. Tailoring distance vector protocols. The destination sequence distance vector protocol is one of the first attempt to customize the classical DBF protocol 18. The key elements of DSDV are an aging mechanism based on monotonically increasingly sequence numbers that indicates the freshness of the route and which is used to avoid routing loops and the count to infinity problems. B. The use of full route updates sent periodically every update interval or incremental route update sent on the topological changes. C. The delay of route updates for the routes that are likely to be unstable, that is, for those for which a new update is on the way towards a node. Reactive protocols. A different approach for routing in mobile environment is routing on demand. The approach is characterized by the elimination of the conventional routing tables at nodes and consequently the need of their updates to track changes in the network topology. On demand routing protocols calculate a path before data transmission. If data traffic is not generated by nodes, then the routing activity is totally absent. For such a reason, they are also called reactive protocols. Reactive protocols is characterized by the following procedures used to manage paths: path discovery, path maintenance, path deletion. Option it is an optional. Data forwarding is accomplished according to two main features: source routing, hop by hop. Position aided protocols. The novelty in the location aiding routing protocols is the estimation of the position of the destination node used to increase the efficiency of the discovery procedure. Only a subset of nodes are queried during the discovery phase, specifically the ones in the so-called request zone nearby the estimate. LAR uses standard flooding as last resort when no estimations are available. The position can be obtained, for example, from the global position system GPS. The request zone is calculated from the expected zone, which is defined as the zone where the destination node D should be located from the viewpoint of the source node S at the current time t1, given that S known its position at some time t0 in the past and its average velocity. Protocol performance analysis. A protocol performance analysis aims to measure two complementary aspects. The first one is how efficiently the routing service is provided with respect a given set of cost indexes, example bandwidth, battery, energy consumption, CPU cycles. The second aspect concerns application oriented metrics. That is the performance seen externally by an application in using the protocol. To evaluate these two aspects, protocol complexity analysis and protocol simulation have been used. The aim of the complexity analysis is to measure at a simplified and abstract setting the resources required the protocol in performing a single protocol operation, for example, the reaction to a link breakage. So, coming out to the conclusion part, many protocols have been proposed in the literature to provide routing in a mobile environment. In this paper, we have illustrated the main techniques proposed to deal with mobility in the case of Unicast flat routing protocols. The experience gained in wired networks have influenced the design of mobile and ADHOC routing protocols in many ways. However, wireless and mobile networks introduce several concerns that make the routing issue completely different from the one provided for the fixed counterpart. For example, the limitation on the battery lifetime and transmission bandwidth, as well as for notion of route stability, lead to a new notion of best route. Also, fairness is an important property of a protocol since using always the same route result in battery drain out for the same mobiles. So, thank you for watching my video. See you in the next one.